I'm sharing my screen. Yeah, today we'll discuss about, in the last class we seen about the SR flip-flop and D flip-flop, that working principle and this Verilog codes, okay, RTL codes. And today we'll discuss about the JK flip-flop and T flip-flop, the working, and we'll discuss the characteristic table, excitation table, and characteristic equation and state diagram. And parallelly, I will try to explain the operation related to this RTL code related to this flip-flops. Okay, one second. Okay, flip-flops. Okay. So here my screen is visible now. So anyone give response so that I will move forward. Okay, thank you. Okay. So see here, first we'll see. So before that we already see in the like what we call SR latch by using NAND gate, we already seen, no? SR latch by using NAND gate. Okay. So before that we'll try to like write one more time. Okay, why? Because this I am going to use in the JK flip-flop also. So here if you see, so I am writing the SR latch by using NAND gate. Okay, so SR latch using NAND gate. Okay, using NAND gate. So this I already explained. Just I am drawing this SR latch by using NAND gate. So this is SR latch. So output will be feedback to input. Okay, output will be feedback to input. And so this one is nothing but S and R, and present state is Qn and Qn bar, and next state is Qn plus 1 and Qn plus 1 bar. Okay, so this is present state and this is next state. Okay, so this one is next state. Okay, and next if you see, so what is the truth table for this? We already seen in the last class. S, R, and Qn plus 1 state. Okay, so here if you see, so 0 0 0 1 1 0 1 1. Okay, so if it is 0 0, what is that state? So the 0 0 invalid state. Okay, 0 0 means what? Invalid state. Okay, so this is invalid state. Okay, 0 1 means what? Set state, no? So 0 1 means set state, and so 0 1 means set state and reset state. Okay, 1 0 is reset state, 1 1 is nothing but memory state. Okay, memory state. Okay, so this I am going to use in the JK flip-flop also. Okay, so if you see, yes, so I'm writing the JK flip-flop. So JK flip-flop, so how it will look like. So if you see the JK flip-flop, so JK flip-flop will be like this. So this is the NAND gate. This is one more NAND gate. And clock is connected to here. This is passage of clock. And here you are giving what? J, and this is K. J and K. Okay, and these are connected to what? These are connected to one more NAND gate. NAND latch. Okay, this is NAND latch. Okay, so output will be feedback like this. And here this input is connected like this. Okay, this input is connected like this. So that means here present state is Qn and Qn bar. Qn bar is connected as a input to the J, input to this J of a NAND gate, and here Qn is connected as the input to K. Okay, input to K. Okay, so this is basic. This is present state, and what is the next state? Next state is Qn, Qn plus 1 and Qn plus 1 bar. Okay, so here first case, so that means if you see the like so if you see the characteristic table, so what are the inputs? J, K, Qn. Okay, this is characteristic table. Okay, Qn, and what are the outputs? Output is Qn plus 1, and so 3 inputs are there. How many possible combinations? 0 0 0 0 0 1, and next 0 1 0 0 1 1, okay, and next 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, so here if it is 0, so here if it is j equal to 0, k equal to 0, we'll see. Okay, so anyway clock is 1 and j is 0, k is 0. Okay, so I will try to draw the NAND gate like so NAND gate means what? Here let us take the first case. What is the first case? Suppose qn is 0, qn bar becomes what? 1, no? So qn bar becomes 1 means this will be feedback. Okay, so this will be feedback means this is 1. Okay, so 1 and 0 and 1. So what you are getting the output? So 0 bar means what? Here you are getting 1. Okay, and this will be feedback. So here 0 will be feedback. So 1 and 0 and so 1 and 0 and 0 bar means what? You are getting 1. Okay, so 1 means what? If it is 1 1, what is that state we got in the NAND latch? Memory state, no? So memory state means this state we can write as what? Either j equal to 0, k equal to 0, whatever the qn you are getting, that is 0 only, you are getting 0. Similarly here 0 0 means you are getting the memory state only. Okay, so this state is nothing but what? Memory state. This is nothing but memory state. Okay, and next case we will see. So what is the next case? J equal to 0 and k equal to 1. Okay, j equal to 0 and k equal to 1. Okay, anyway clock is 1 only, and I will see this case. So that means qn is what? So qn I am taking as 0 and qn bar is 1. So qn bar is 1 means what? This is 1 and this will be feedback. So this is what? This is 0. Okay, so 0 means what? 1 second. 0 means yeah. So if you see this, okay, so if you see this 1 1 j equal to 0, j equal to 0, k equal to 1, no? Okay, k equal to 1, 0 1. Okay, so first case we will see. First case, when the qn equal to 0 means what is that case you are getting? That means you are getting the memory state only. So the 1 1 means what? Here you are getting 1 and here also you are getting 1. Okay, so that means you are getting memory state only. So that is what 0 and 1. Okay, and next case I will say. Next case, so this is what? This is 1 and this is 0. Okay, so this is 1, this is 0 means what? 0 will be feedback. This case, okay, if you see this case, you will get memory state. I think 1 second, I will check this case. So first one is memory state only. Second case I will check. Okay, second case I will check. Second case, what is the second case? So second case I am checking. Okay, second case, so this is the first case, second case, third case and fourth case. Okay, so second case if you check, what is that? J equal to 0 and k equal to 1. Okay, j equal to 0, k equal to 1, and anyway clock is 1 only. Okay, clock is 1 only, and let us take qn is what? 0, qn plus 1, qn bar becomes what? 1, no? So this will be feedback. So that means this becomes 1 and anyway 1 1 and this one is 0. Okay, so that means 0 0 this AND operation, 0 bar means here you are getting 1. So 1 AND operation means what? 1 bar means you are getting 0. Okay, so 1 0 means in SR latch 1 0 means what? 1 0 means here you need to get set state. Okay, 1 0 is reset state. Okay, in the SR latch you see 0 1 set state, 1 0 reset state, and 1 1 okay, 1 second, 0 here you are getting j equal to 0 1. Here you need to get this case, you need to get this one should be 0 and this one should be 1. Okay, this one should be 1. So when it is 0 1 means you are getting this case is what? Set state. Okay, you are getting 0 1 second, set state you need to get. Okay, so sorry, reset state only. Okay, so 0 1 means what? You are getting 0. Okay, so 0 1 means you are getting 0 only. Okay, so that means what? Reset state you are getting. Okay, so that means 1 0 means what? 1 0, so you are getting reset state only. Okay, so that means this one is what? This one is reset state. Okay, 0 0 means memory state, and 0 1 0 1 means reset state. Reset state. Okay, reset state. And next case, third case we'll see. Okay, so third case, so if you see the third case, uh, so j equal to what? J equal to 1 and k equal to 0. Okay, and anyway clock is 1 only. And I will see the first case. That means suppose q is 0, qn bar is 1. Okay, so qn bar is 1 means what? This is 1. Okay, this will be feedback, and this is what? 0. Okay, so and operation of 1 is what? 1 bar means what? Here you are getting 0, and here 0 bar means what? Here you are getting 1. Okay, so that means 0 1. So 0 1 for the NAND latch. What is the state? Set state. Okay, so you are getting what? Set state. Okay, so this is nothing but set state. So qn bar is set state. Okay, so qn bar is what? Set state. Okay, so that means here when it is j equal to 1 and k equal to 0, you are getting set state. Okay, and fourth case we'll check. Okay, so whatever the unused state is there, that we are going to make as a used state in the JK flip flop. Okay, so that is the advantage of JK flip flop. That means SR flip flop, you are getting, if it is 1 1, that is unused state, no? So that you are making as used state. Okay, that I will explain you. So anyway clock is 1. Okay, clock is 1, and here let us take first state. Qn is 0, qn bar becomes 1. Okay, so this will be feedback. So this is 1, and this will be 0. Okay, so 1 bar means what? Here this becomes 0, and this is what? So 0 bar means what? 1. Okay, 0 bar means 1. For the SR latch by using NAND gate, 0 1 means what? Set state. Okay, so that means it becoming 1, and if it is 1, it becomes 0. Okay, and we'll see the next case. So what is the next case? We'll see the next case. If you see the next case, yeah, so I'm taking qn as 1 and the qn bar as 0. Okay, and now what happens? It will be feedback, no? So that means here anyway j is 1, and so this will be feedback. So qn bar is feedback. This is 0, j is 1, and clock is 1. And next here k is 1, clock is 1, and which one will be feedback? So here you are taking qn as feedback. This is 1. Okay, so that means so 1 bar means what? 0 bar means you are getting 1 here, and 1 bar means you are getting 0. Okay, so for 1 0 latch, for a NAND latch, what is that? Reset state. So that means if it is present state is 1, it is toggling to what? Next state is 0. If present state is 0, it is toggling to what? 1. You are getting 1. So this state is nothing but if present state is 0, you are getting the next state as 1. If present state is 0, you are getting next state as 0. Okay, so this state is nothing but we call as toggle state. This state we call as toggle state. So whatever the unused state is there, that we are making as used state in the JK flip flop. Okay, that is the advantage of JK flip flop. Okay, hope you understood. Okay, and next what I will do, so this is characteristic table. By seeing this characteristic table, I can draw the truth table. Okay, so what is the truth table? Here you see truth table. This is j, k, qn plus 1 and state. Okay, so here you see. So how many possible combinations? 4 possible combinations. 0 0 0 1 1 0 1 1. Okay, so if it is 0 0, what is the state? Qn, memory state. Okay, and next if it is 0 1, reset state. 1 0 set state, 1 1 this is toggle state, qn bar is toggle state. Okay, so this is a toggle state. Okay, so this is the truth table for JK flip flop. Okay, and how you will draw the so that means how you will draw the characteristic equation. So characteristic equation you will get from which one, characteristic table only. Okay, so by using the K map only I will draw this characteristic table, characteristic equation. Okay, so what is this characteristic equation? So first this is qn plus 1, I can write as what, a summation of m of whatever the min terms are there you need to write. Okay, this is 0 1 2 3 4 5 6 7. Okay, so what are the min terms? 1 4 5 6. Okay, 1 4 5 6. So just draw the K map. Okay, you draw the K map. So here this is what are the inputs? J, K, Qn. Okay, 0 1 0 0 0 1 1 0 1 1. Okay, and so 0 1 2 3, next 4 5 6 7. Okay, so write the min terms, 1 4 5 6 7. Okay, this is one quad, and this is one pair. Okay, so quad will eliminate, you know that quad will eliminate two variables, no? So here k and qn are eliminated. So what is qn plus 1? Qn plus 1 you can write as j plus, pair will eliminate one variable, so k bar qn. Okay, this is the characteristic. If you get the characteristic equation, you can draw the logic diagram also. And from here you need to draw the excitation table. How you will get the excitation table? From the characteristic table only you will get the excitation table. Okay, so I am drawing the excitation table. Okay, from the excitation table you will get the state diagram. Okay, I am drawing the excitation table. Okay, so how you will draw the excitation table? Present state and next state, qn plus 1, and inputs. What are the inputs? J and K. Okay, so how many possible combinations? 4 possible combinations, 0 0 0 1 1 0 1 1. Okay, now you see, so that means qn plus 1, J and K. Okay, if it is 0 0, see the possibilities, 0 0, so qn and qn plus 1 are 0 0, and this is also first one, qn and qn plus 1 0 0. So 0 0 means what? J and K values are 0 0 0 1. So if you combine, what you are getting? 0 don't care. Okay, so this is nothing but 0 don't care. Okay, and next one, if it is 0 1, okay, 0 1 means what? Where you will get this is the second case, 0 1 and 0 1. Okay, so 0 1 0 1 means what? 0 0 1 0 1. What you are getting? 0 1 0 1 0 1 0 1 1 0 1 1. You are getting 1 0 1 1. Okay, so if you combine, this is 1 don't care. Okay, so this is 1 don't care. Okay, so this is 1 don't care. Okay, and next case you see 1 0. Third case 1 0. Where you will get third case? This is third case, and here this is third case. Okay, so third case, if you see 1 0 0 1 1 1. Okay, 0 1 1 1. Okay, this is don't care 1. So this is don't care 1. Okay, and fourth case you check 1 1 1 1, where you will get this is fourth case. This is also fourth case. See the present state and next state, 0 0 0 0 and 1 0, 0 0 and 1 0. If you combine, what you are getting? Don't care 0. So this is what? Don't care 0. Okay, so you got the excitation table. Next you need to draw the state diagram. How to draw the state diagram? By seeing this excitation table only you can draw the state diagram. So you are at 0. Okay, you are at 0. So that means present state is this is the present state and this one is next state. Okay, present state is 0, it will be in the same state only. What are the inputs? 0, don't care. Okay, and your present state is 0, it will go into the next state. What it is going to next state 1, it is going to the next state 1. And what are the inputs? 1, don't care. Okay, present state is 1, what is the next state? It is coming to 0. What are the inputs? Don't care 1. And present state is 1 and it will be in the same state. What are the inputs? Don't care 0. Okay, so for the JK flip-flop, okay, for the JK flip-flop, first I drawn the basic logic diagram and I analyze the characteristic table. From the characteristic table I will get the truth table, and from the characteristic table you will get the characteristic equation. From the characteristic table you will get the excitation table. From the excitation table you will get the state diagram. Okay, so this is about the basic JK flip-flop. Any doubts or any queries? Shall I move forward? Yes, no? Okay, so I am going to the programming part. Okay, programming part I am going. See here, so I wrote for the JK flip-flop. So I am using the behavioral modeling. Hope my screen is visible. Okay, okay, see here, yes, JK flip-flop. Okay, so JK flip-flop, if you see the JK flip-flop, okay, so here I wrote the JK flip-flop. If you see, I'm expanding this. Yes, see here, first I'm starting the module and my module name is what, or identifier is JK underscore flip-flop. Whatever the inputs are there, that I am initializing with wire data type. What are the inputs? Input wire clock, input wire reset underscore n, input wire j, input wire k, and output. Here I am using behavioral modeling, that's why I need to initialize the output as what? Q. Okay, always at the rate passage of clock or negate of reset. Okay, a passage of clock or negate of reset. Okay, begin. Okay, I told you, no, so we need to use asynchronous active low reset. Okay, so how we are using asynchronous active low reset means in the sensitivity list you need to use this one. So passage of clock or negate of reset you need to use. Okay, if not of reset, so first you need to reset the circuit. If not of reset means what? Active low reset. If reset equal to 0, you are making what? Q equal to 0. Okay, the output you are making as 0. Else begin, I am using a case statement. Okay, I am using a case statement in the behavioral modeling. These are procedural statement. We can call it a procedural statement. We can use if, case, while, repeat, for. Okay, so this is like a switch modeling. That means I am using J and K in the concatenation operator. J and K. These are the values. If 2 tick binary 0 0, so Q equal to what? Q, no change. Okay, if 2 tick binary 0 1, Q equal to what? 0, reset state. 2 tick binary 1 0, what is that state? Set state. 2 tick binary 1 1, what is that state? Toggle state. And end case, and this begin I need to end. Okay, after that this begin I need to end, and end module. Okay, so this is the Verilog code I wrote for JK flip-flop. And if it is a test bench, okay, if it is a test bench, I wrote in the simulation. See here, I wrote in the simulation TB JK flip-flop. Okay, so test bench 5 steps will be there in the test bench. First module, the test bench, this is the test bench name, TB underscore JK underscore flip-flop. Whatever the input variables are there, that I need to initialize with reg data type, reg clock, reset end, and reg j and k. And output I need to initialize with wire data type, wire q. I need to instantiate. Okay, whatever the design is there, I need to instantiate. So what I am using, I am instantiating connection by name. Okay, connection by name. So whatever the variables present outside this are nothing but design variables or design inputs or outputs, and whatever the variables present inside the bracket are nothing but test bench inputs or outputs. Okay, UUT is nothing but unit under test. Okay, and I need to generate the clock. So for generation of clock, first you need to initialize the clock to 0. Okay, always #5 clock equal to not of clock. Okay, I am generating means with a time period of 10 time units. Okay, so I am generating clock equal to what? Not of clock. Okay, so not of clock. Okay, next what I am doing? Next, 1 second. 1 second. Yeah. So here next, next what I need to do, so I need to like so here integer I initial begin. Whenever I'm using this EDA playground, I need to use $dump file jkflipflop.vcd $dump vars, okay, tb jkflipflop, and whatever the initial reg variables are there, I need to initialize to 0 and apply the inputs for I equal to 0, I less than 4, I equal to I plus 1, j comma k equal to I of 1 is to 0, okay, and end. So this is the test bench, okay, and after that what I need to do, one second, after that, so here I want to see the circuit, elaborate the design, okay, elaborate the design. I want to see the, so netlist is generating. Here you see. So see here, how many inputs? J and K are nothing but, one second, I generated for TFlipFlop. Okay, as I told you, no. Suppose for which one you are generating the simulation or this elaborate design, that you need to right click and set as stop. Okay, you need to right click and set as stop. For GK-flip-flop also I am seeing the simulation, so I need to right click and set as stop. Okay, elaborate design. Elaborate design. See here, this is the JK flip-flop. Netlist generated, schematic generated for JK flip-flop. Like muxes are there, two muxes are there, J and K inputs are given, and reset is directly given as a to the clear signal. And this is the netlist. Okay, netlist. Okay, and next I want to see the simulation. Okay, I want to see the simulation. So here what I need to do, run the behavioral simulation. Run the behavioral simulation. So in the, one second, here it is not in TCL console, it's not getting. I want to see the simulation part. So fit to page. See here. So that means this is active low reset. That means when reset equal to what, 0, you are not getting any outputs. Output is also 0 only. Okay, output is 0 only. So reset. So when reset becomes 1, it is going from where to where, reset mode to functional mode. Okay, it is going from reset mode to functional mode. So during passage of clock, here what, j equal to 0, k equal to 0. You are getting what, j equal to 0, k equal to 0. It will be memory state. So what is the memory state? 0 only. It will be in the previous state, memory state. Okay, and during this passage of clock, what happens? J equal to 0, k equal to 1. So here also reset state only. Okay, so when j equal to 0, k equal to 0, it will be reset state only, no? So we already seen the truth table for this. So if you see the truth table, j equal to 0, k equal to 1, where this truth table, okay, so this truth table, j equal to 0, k equal to 0, k equal to 0, memory state, j equal to 0, k equal to 1, which state? Reset state. Okay, and similarly j equal to 1, k equal to 0, so that means set state. Okay, here during the passage of clock, j equal to 1, k equal to 0. Okay, so j equal to 1, see here, j equal to 1 and k equal to 0. Okay, k equal to 0 means what, set state. Okay, and during this passage of clock, what happens, j both becomes 1, so j equal to 1, k equal to 1 means what, j equal to 1, k equal to 1 means what, toggle state. So toggle state means what, initially it is what, it is 1, it is toggling from 1 to 0, okay, and here if you see, during this passage of clock, both are 1 only. Initially it is 0, it is toggle from 0 to 1, and here also both are 1 only. Initially it is 1, it is toggling from 1 to 0. During this passage of clock, so initially it is 0, it is toggling from 0 to 1. during this passage of clock both are 1, j and 1, j equal to 1, k equal to 1. So initially it is 1, it is toggling from 1 to 0. Okay, so like this you need to analyze the truth table for the JK flip flop in the simulation part. Okay, yes. Is it fine? Do you understood any doubts or any queries in this? Shall I move forward? Yes. Next I am going for T flip flop. Anyone give response? Elaborate design and netlist the same. Elaborate design netlist. Yeah, it is generating the netlist. Dollar dump means that is there in the like we will get in the EDA playground. Okay, this is like one type of function we are writing, and this will come in the EDA playground. And elaborate design, that is generating the netlist only. No, netlist that is same only. Elaborate design. And next I am going for the T flip flop. So T flip flop. So what is T flip flop? T flip flop means we are using two states in the T flip flop. Okay. So that is nothing but so if you see T flip flop, basically we are using in the counters. Okay. So here in the truth table we are using which state means in T flip flop we are using this state, and we are using this state. Okay, these two states only we are using in the T flip flop. Okay, so here what you are doing in the T flip flop, just so I am writing the T flip flop. So you have a JK flip flop. Okay, so you have a JK flip flop. So once again, shall I draw the JK flip flop? Okay, so I'll draw the JK flip flop. So this is one NAND gate, and this is one more NAND gate, and clock is given like this. Okay, passage of clock. This is passage of clock, and this one is letter, you know, that J, and this one is what? K. This one is J and this one is K. So these both are connected together. Okay, and you are giving the input as what? T. You are giving the input as T. Okay, and here one more NAND latch is there. NAND latch, the feedback input connected back to back. And this one is nothing but QN and QN bar, present state, and what is the next state? QN plus 1 and QN plus 1 bar. Okay, so here this input is connected to QN bar, and this input is connected to QN. Okay, so that means this is T flip flop. So what are the states? That means if you see the characteristic table, what are the states? T, QN, okay, and QN plus 1. Okay, so that means two inputs are there, and how many possible combinations? 0 0, 0 1, 1 0, and 1 1. Okay, so if it is 0 0, so if it is 0 0 means what? If T equal to 0, okay, what happens? If T equal to 0 means, J equal to 0, K equal to 0, and clock equal to what? 1, and Qn equal to what? 0, and Qn bar is 1. So this will be feedback. So this becomes what? 1, and this becomes 0. Okay, so that means here NAND operation, 0 bar means what? Here you are getting 1. Here 0 bar means 1. Okay, so 1 1 means in the NAND latch we already seen. What is that state? Memory state. So if it is 0, you are getting 0. If it is 1, you are getting 1. Okay, so this is nothing but memory state. If T equal to 0, what you are getting? Next state I think you can analyze, that is memory state. Okay, and next if T is 1, okay, if T is 1, so what? J equal to one second, J equal to what? J equal to 1, K equal to 1. Okay, anyway clock is what? Clock is 1 only. Okay, so that means so if this one will be feedback, this is 1, and here you are getting 0. Okay, here you are getting 0. Okay, so that means 1 1 means what? Here you are getting 0, here you are getting what? 1. Okay, 0 1 means what? So 0 1 means if you are giving 0, here you are getting the set state. Okay, in the this one we already seen, no, NAND latch. 0 1 means what? Set state. Okay, so here you are getting 1, and this is 1 means you are getting 0. Okay, and similarly next case, you take qn is 1 and qn bar is 0. So next case, what you will get? This is 1 means what? You are getting 0, you are getting 1. Okay, so that is nothing but toggle state. That is nothing but what? Toggle state. Only two states are there, memory state and toggle state. When t equal to 0, which state? Memory state. When t equal to 1, which state? Toggle state. So you can draw the truth table. So what is the truth table? T, qn plus 1 and state. Okay, so here if you see, this is 0 qn. What is this state? Memory state. Okay, 1 means what? Qn bar. Qn bar means toggle state. 1 means toggle state. Okay, and next I need to draw the excitation table. By seeing this characteristic table, first characteristic equation. What is characteristic equation? Just draw the k map for qn plus 1. Okay, k map for qn plus 1. So what is characteristic equation? Qn plus 1. This is so two variable k map. How many? So if you see how many inputs t and qn, 0 1 0 1. 0 1 2 3, and what are the minterms? So minterms are summation of m of 1 comma 1 comma 2 1 comma 2. Okay, 1 comma 2 means what? Here you are getting diagonally, so that means this is XOR gate only. Okay, so qn plus 1, or otherwise you write, so this is what? T bar tqn bar and next tqn bar plus t bar qn. So qn plus 1 equal to what? T XOR of qn. Okay, this is characteristic equation. And next excitation table. If you see the excitation table, so by seeing this characteristic table, you can draw the excitation table. Okay, so how I can draw the excitation table? See here, it's like a XOR gate only you are getting. Okay, excitation table. So present state and qn plus 1 and t. Okay, how many possible combinations? 0 0 0 1 1 0 1 1. Okay, if it is 0 0, so what is that state? 0 0 means what? This one. Okay, t equal to 0. Okay, t equal to 0. And next 0 1, second case. 0 1 0 means what? T equal to 1. Okay, 1 0 1 0 1 0 means what? 1 0 means t equal to what? 1. T equal to 1. Okay, 1 1 means what? 1 1 means this state. So fourth case, 1 1 means t equal to 0. It's like XOR gate only. If you remember the diagram, means a logic diagram for logic truth table for XOR gate, same as the excitation table only. And a state diagram I am drawing. What is the state diagram? So present state, this is 0. It will be in the same state. What are the inputs? 0. Okay, present state is 0. It will going from where to where? 0 to 1. 0 to 1. What is the input? 1. Okay, and if you are at 1, what is the next state? Next state is 0. What is the input? 1. Okay, if you are at 1. Okay, you are at 1. I am seeing the excitation table only. I am drawing the state diagram. Okay, so it will be like same 1. Okay, input is 0. It will be in the same state, and input is 0. Okay, this is the state diagram. Okay, hope you understood this TFlipFlop. What we discussed, this one first characteristic table and first diagram, and we are using only two states, that is memory state and toggle state. When J and K are connected, you are getting this TFlipFlop. Okay, so characteristic table and truth table and characteristic equation and excitation table and state diagram. Okay, state diagram. Okay, so this one, I will show the program for this. This is TFlipFlop. If you see the TFlipFlop, one second. I'm expanding this. First, so it will start with module and the module name. What is the module name? T underscore flip flop, and whatever the inputs are there, input wire clock, input wire reset underscore n, and input wire T, and only one input and one output, no, Q. Okay, whatever the output is there, you initialize with the reg. Okay, reg data type. So I'm using asynchronous active low reset. That's why always at the rate in the sensitivity list, passage of clock or negate of reset begin. If not of reset, okay, if not of reset, Q equal to what? 0. Okay, I'm initializing, I'm resetting the output. Okay, else if T, else if T means what? If T equal to 1, Q equal to what? Not of Q. This is nothing but toggle state. Okay, else means what? If T equal to 0, Q equal to what? Which state? Memory state or hold state. Okay, T will be T equal to memory state or hold state. Okay, and end module. So here this begin you need to end, no? So begin you need to end. Sorry, here where you need to end. Okay, this begin you need to end and end module. Okay, so always after I will always there is a begin, no? So begin and end module. Okay, and next coming to the test bench. So whatever I want to see the design, right click, set as stop module, set as stop module, TFlipFlop, and similarly I want to see the simulation part, that also you set as stop module, set as stop module, set as stop module, and I want to see the elaborated design. So just go to RTL analysis and make the elaborated design. You can see the elaborated design. See here, T input, clock, passage of clock, and this asynchronous active low reset. Okay, so synchronous active low reset means it is coming through the mux. Okay, special timing analysis is required for that one, but here directly it is coming. Timing analysis is not required for this. Directly it is given to the clear signal. Okay, this is active low signal. Okay, asynchronous active low reset, that is given to the clear signal. Okay, so as you know that clear and what are these? Clear and preset are asynchronous inputs. It's irrespective of input and clock. When it is activated, it will force the output to 0. Okay, and Q is given to this Q. Okay, this is basic elaborate design. And next, run the simulation, run the behavioral simulation. Run the behavioral simulation. Expand this. Fit to page. One second. Where is this? This one. Okay. Fit to page. Yes. See here. So during reset equal to 0, it will be in which state? Reset state only. Okay. Active low reset. So the reset will be in active state. So that means here reset is going from where to where? Reset state to reset mode to functional mode. Okay, so when it is going from reset mode to functional mode, this is not asynchronous. Okay, so when it is going from reset mode to functional mode, this is synchronous with the clock. Okay, so here during passage of clock only the output will change. Okay, so during this passage of clock it will check for T. So T equal to what? 0. So T equal to 0 means it will be the memory state. So what will be the previous state? 0 only. So it will be 0 only. Okay. During the next passage of clock, what happens? T becomes what? T becomes 1. Okay. During this passage of clock, T becomes 1. So T becomes 1 means what? It will toggle. Okay. It will toggle. So previously it is 0. It becoming what? 1. Okay. It is toggling. And during this passage of clock, now what happens? T becomes what? 0. Okay, T becomes 0 means what? It will be the memory state only. What is the previous state? Previous state is 1 only. It will be 1 only. Okay, and during this state, see here, during this state, TV becomes what? 1. So it should go to toggle state. So previous state is 1. It is going from 1 to 0. 1 to 0. Okay, see here. Now T becomes 1. So it should toggle. So previous state is 0. It is changing from 0 to 1. And here also T becomes 1. Previous state is 1. It will toggle from 1 to 0. And here also T becomes what? T becomes 1. Previous state is 0. It will toggle from 0 to 1. Here also T becomes 1. So that's why previous state is 1. And it is toggled from 1 to 0. Okay. I think test bench I didn't explain. Just test bench is same only. 5 more steps are required. That same as that whatever I explained in the JK flip-flop. Test bench is same only. see here test bench. This is the test bench. Okay, first what I need to do, first whatever the inputs are there, that I initialize to reg variables, reg clock reset underscore n, reg t, and wire q. I need to instantiate connection by name. Whatever the variables outside the bracket are nothing but variables related to design, and whatever the variables inside the bracket are nothing but test bench. Okay, and generation of clock. This is the generation of clock, and integer I initial begin. This when you are using this EDA playground, you can use this $dump file t underscore flipflop.vcd and $wires. If you are using Xilinx Vivado, not required. Okay, if you are using if you want waveform in EDA playground, you want this these two header two files. Okay, and reset underscore whatever the reg variables are there, I need to initialize to 0, and so this is resetting for 10 time units. After 10 time units, I am making reset equal to 1. So this is reset mode. After that, this is functional mode. Okay, and I need to give you the test cases. Okay, stimulus for I equal to 0, I less than 4. So 4 possible combinations. No, I equal to I plus 1 and t equal to I modulus of 2. So that means modulus of 2 means I am giving alternate zeros and ones. Okay, modulus of 2 means what? I am giving alternate zeros and ones, and for every 10 time units I am giving, and continuously toggling is observed for 50 time units. Okay, so 50 time units I continuously see in the toggling condition. Okay, when t equal to 1, toggling is happening, and dollar finish, I need to finish this simulation. I am using the system task dollar finish, and after that end and end module. Okay, so this is the basic test bench, and this simulation part also you will see. Okay, yeah, so this is about the JK flip flop and T flip flop. Any doubts or any queries?